This is video number 1 for Bryan Triple Flex Quiz 2. You'll see here I will add another quiz here. Quiz 1 you've already completed. This is the instructions for Quiz 2. But there's a few things I wanted to go over that you probably saw in Quiz 1. Might have been a question, but some important things that I wanted to make sure and cover. So we look at page 1 of the diagram. This is the page 1, which is the left-hand page. When you looked at this right here, I didn't really go into a whole lot of detail about this single point power connection here, but it really is a very important part of this piece of equipment and most of the equipment that we typically service. So I want to go back, leave this page open. I'll go back to the main tab and I want to open up the terminology page. I converted the terminology page from a Word document to a PDF document to hopefully makes it a little bit easier for you to navigate and do things like Zoom. So one thing I wanted to explain on that first page was this single point power connection. That's that power connection right here. It's done for safety reasons. In the OSHA energy control procedure for lockout tagout, there is a statement that says the machine or equipment has a single energy source which can be readily identified and isolated. And that's very important on pretty much every piece of equipment that you work on, that you can isolate and identify and isolate the source of power and shut it off. That's primarily why we use single point power connection, or why manufacturers use that for the equipment. Of course, we know there's a 3-phase blower motor here. There's single phase power going to a transformer for our 120 and 24 volt control circuits, but everything is fed from that single power source. Going back to the drawing here, a little detail on this general alarm tie-in point. And if you remember statement number 1 up here at the top, it said that if you are the person installing the field installed devices, it is your responsibility to do them correctly. And I wanted to make sure that this was something you know exactly how it should be done to tie in this general alarm. So going back to the terminology page, you'll see here that in red I've drawn in how you would connect an alarm relay, and it would typically be something like this IDEC or ice cube relay. The coil of the relay would be from terminal 12 to 2, and I think that was one of your quiz questions. And this contact here would be for monitoring, for remote monitoring, either through building automation or some type of alarm output. It is considered a dry contact. A dry contact is a no voltage contact where the contact is usually used to indicate an event, movement, closure, alarm, etc. And in this case, we're showing an alarm, but the term dry contact means that no power from the boiler or the control system here, which is energizing the coil, no power from there goes to these contacts. They are completely dry or completely separated, and I think that's important, and I'll go into a little more detail on that here in just a second. But the other important thing here, it was 120 volt. We need to make sure that the relay we put here is a 120 volt coil, and we need to make sure that the power rating of that coil, that relay, is less than 75 VA. And I looked up the information for this 2-pole, double throw IDEC relay here. It's a part number RH2. Well, that's actually the sub-base part number. When you have it on 50 hertz, it's 1.4 VA. 60 hertz is 1.2 VA. So 1.2 VA is the power consumption of the relay coil. And here it says that we can use up to a 75 VA device, and of course we're well within that range, so that's a good choice for the alarm relay, and that's how you would wire it in. Go back to the main menu, and I'm going to open up diagram page 2, and I wanted to go into specifics on this boiler enable disable point right here between terminal 19 and 20. It says to remove the jumper. Go back to the terminology page and scroll down. This is the field install boiler demand enable disable relay. We're going to remove this jumper and we're going to put this in. And again, very important, the contact circuit for the voltage going from 19 to 20 is completely isolated from the relay coil here. When we have power on 19, this is our 24 volt power coming from the transformer, goes to terminal number 1. Our neutral from our transformer comes over to terminal number 2 here. So we have our 24 volt power. I think that was a quiz question for that, testing 24 volt power there. Now we need to get 24 volt power to terminal number 3 in order to tell the boiler that it's time to start. That's our enable disable. And we have to do that by closing the contact between 19 and 20. So when 24 volt power from terminal 19 is fed to terminal 20, terminal 20 has wire connections that energize both the R1 relay and the stat input, which is J8-3. Here is 19 to 20. Once we put power on 20 by closing this contact, we send power to R1 relay, which over on page 1 makes a contact that lights a green light. I think that was also a question. It was a green enable light that it lights. And we also get power from terminal 20 over here to J8-3, which tells the controller that it is time or that the boiler is enabled to run. And you'll see that the boiler actually has a touchscreen display for setting the temperature set points. So that's how we get the boiler in a condition that it's ready to go. So if you scroll down a little bit more on the terminology page, I took a picture of a plug-in relay. I pulled the cover off of it, and I wanted to go over this just to make sure there's no doubt about this, that when you're looking at this relay and how it plugs in, down here is where you find the coil connections, and here are the contact connections. And actually, this is the 3-pole relay that I took a picture of. But I want to make sure you see that the connection here to the normally closed contact, the connection here to the normally open contact, and this is what we call common. It has a wire that goes over to this reed. And here is the magnetic coil. This is the iron piece that pulls down. When the coil is energized, this terminal right here and the terminal on the opposite side comes down a little wire you can barely see right there, energizes that coil, creates an electromagnet, pulls this down. This movable contact here that goes from that terminal pulls down and makes contact here. That's closing the normally open contact, and as soon as that happens, the normally closed contact goes open when it's energized. But very important to understand that the power coming to this coil that creates the electromagnet to move the contacts up and down is completely isolated from any of the power that comes in or goes out of the contact connections. Okay, back to diagram page 1. Now that we have got a good understanding of the transformer and the power coming over, we talked about the control switch. We talked about the relay on page 2 that closes a contact or energizes to close this contact, give us a green enable light. One of the questions that was on quiz number 1 was, does the control power switch control all the 120 volt devices? And no, it doesn't. Here is terminal number 1. Here's the line coming off of terminal number 1. We're going to follow that down. It comes over to the POC switch. This is something I'll add to the terminology page because it's very important. POC stands for proof of closure, and you see, now that you know that it is proof of closure, and you see here where it says wire nut in gas valve if not used, that means that they provide this wiring to this switch. And if the gas valve that is on the particular boiler does not have a proof of closure switch, you have to put a wire nut on it. Certain codes require proof of closure switch. What this is a physical switch in the gas valve that not just it doesn't monitor whether the actuator is energized or not to tell the gas valve to open. It physically monitors the position of the valve to make sure that the valve is closed. If you had a gas valve that's stuck open, you definitely would not want to try to light that boiler. That would be an explosion that would damage the boiler. So making sure that the gas valve is closed, and this is proof of closure, is very important. And because it's not, it is powered upstream or before the control switch, there is always power on that proof of closure switch, even when that control power switch is turned off. That's kind of important. So we'll follow it down. It comes all the way down to J6 terminal number 5, POC. That's where the proof of closure switch ties in. This is an input into the Honeywell controller that says, yes, the proof of closure switch is closed, or no, it's not. And it's used to make decisions. You know, any input is used to make a decision as to what to do in the sequence or to turn something on or off. You see here it says POC, proof of closure, but it also says PII, which is also very important to understand, that PII is pre-ignition interlock. Absolutely, before any ignition, you have to know for sure that that proof of closure switch is closed and that the valve is in fact closed. Pre-ignition interlock. Anytime you see an alarm on a boiler that says pre-ignition interlock, you almost always have to think of this is something very serious. You need to take a look at because it will not allow the boiler to go into any ignition sequence until it sees this is at the correct position. And on this, it is proof that the gas valve is closed. Obviously, you don't want to blow anything up, so you got to make sure that that proof of closure switch is in the correct position before you go into any type of ignition. So you think about this. If this fuse was blown for some reason and you had 24 volt power, this fuse was still okay, and you had 24 volt power in the controller, you would probably see an alarm that would say pre-ignition interlock because you're not getting the power you should, and regardless of whether the control switch is on or off, it's still going to that proof of closure. So I'll add those terms to the terminology page. We'll follow the 120 volt power down from terminal number 3. You see here it comes down, comes across here. There's a connection and it goes to J48. So when power goes to J48, we need to see what that does, because that's the next thing as we're following our diagram down, and we'll get to this part here in just a minute. Okay, I'm down to just a minute or two left on this video, so let's take a look at what is J48, where we're sending the 120 volt power into. We'll go back to the main menu, and I want to go to the R7910A Sola FSG. When I open up that, I'll scroll down to page 16 because that's where it identifies the different terminals. And here is J48. It says it's L1, which is line 1 or power, 120 volt power right there, to power the power UV. What does UV stand for? Well, maybe that's something I should add to the terminology page. That is ultraviolet. For this boiler, when it senses there is a flame present, it does that by using an ultraviolet scanner. And this would be a good time for me to go back to the terminology page and spell out specifically what UV stands for and give you a little bit of detail about an ultraviolet scanner.